Hello friends, welcome to the session on multivibrators. In this session, we'll be discussing about bistable multivibrator. In this session, we will see what is the circuit diagram of bistable multivibrator, the working of bistable multivibrator, and also we will draw waveforms for bistable multivibrator. Friends, as you know that you are viewing this session on my YouTube channel Learn with Prakash Kanade, and do subscribe to the channel to see many more videos on the subjects of electronics and computer science. So let us start the session with the question what we mean by bistable multivibrator. As we know, multivibrator is an electronic circuit which has two states, and these states are either stable states or quasi-stable states. Bistable multivibrator is a multivibrator of which both the states are stable states. That is, this multivibrator has two stable states. As shown in this diagram, when initially the circuit is on, it will go into one of its stable state. When the trigger pulse is applied, then it will go from one state into another state. And again, when the next trigger pulse is applied, then it will come back to the original state. That is, in order to generate one square pulse to the output of the bistable multivibrator, we require two trigger pulses at the input of the bistable multivibrator. So one can easily observe that the bistable multivibrator is a multivibrator which do not have any quasi-stable state or temporary stable state. Bistable multivibrator is a very popular multivibrator and it can be called as a flip-flop. This multivibrator is used to store one bit of information, and therefore in computer memory this circuit is widely used. Bistable multivibrator will produce a single output pulse when the two trigger pulses are applied at the input of the bistable multivibrator. Like other multivibrators, bistable multivibrator will also has two states. With transistor Q1 on and Q2 off is one state of the bistable multivibrator, and another state of the bistable multivibrator is Q1 off and Q2 on. So bistable multivibrator will consist of two transistors, and these transistors cannot be simultaneously in the on state or in the off state. Bistable multivibrator can be used as a flip-flop where flip-flop can store one bit of information. Bistable multivibrator is also very widely used in digital communications. Now let us go for the circuit diagram of bistable multivibrator. As shown in this diagram, bistable multivibrator consists of two transistors Q1 and Q2. Emitter of both the transistor is grounded. Base of Q1 is connected to the collector of Q2 through R2C2 combination. Base of Q2 is connected to the collector of Q1 through R1C1 combination. Base of both the transistor is connected to the negative power supply through the resistance, and collector of both the transistor is connected to the positive VCC. So collector of Q1 is connected to the base of Q2 through R1C1 combination. Similarly, the collector of Q2 is connected to the base of Q1 through R2C2 combination. So one can easily see that the circuit is exactly symmetrical along the central line. Both the transistors base are connected to the minus VBP power supply through the resistances. It means that this is a multivibrator which will require three terminal power supply, positive, ground and negative. Emitter of both the transistor is connected to the ground terminal. Resistances RL1 and RL2 are the collector resistances of which one terminal is connected to the positive VCC. Output of this multivibrator can be obtained either at the collector of Q1 or at the collector of Q2. Now let us understand how this circuit works. Now initially when we switch on the power supply for the bistable multivibrator will go into one of its stable state. Say for example, initially the circuit is in the stable state with Q1 off and Q2 on. Now the bistable multivibrator will continue to remain in this state unless and until some trigger pulse is applied. In order to change the state of the bistable multivibrator, we need to apply a positive going trigger pulse to the base of off transistor, or you can apply a negative going trigger pulse to the base of on transistor. When the positive going trigger pulse is applied to the base of Q1, then we know that the instantly positive voltage or base voltage of Q1 rises. When the base voltage rises, base current rises, collector current rises, and therefore collector potential decreases. This decrease is immediately communicated to the base of Q2. And because of the regenerative action, we can easily observe that the circuit, the transistor Q1 will go into the on state and the transistor Q2 will go into the off state. That is, the bistable multivibrator has now switched the state and it has gone into the another state. This state is also a stable state of the bistable multivibrator. So this circuit will remain in this state unless and until again some trigger pulse is applied to the circuit. When again a positive trigger pulse is applied, but this time not to the base of Q1 but to the base of Q2, then the transistor Q2 will go into the on state and the transistor Q1 will go into the off state. That is, the bistable multivibrator has returned back to the original state. So we observe that this multivibrator will change the state only when some trigger pulse is applied, and that is the reason this circuit can be used to store the 1 bit of information. So we observe that the bistable multivibrator has returned to the first stable state again when the second trigger pulse is applied. Now we can easily draw the waveforms for the bistable multivibrator. Initially, we suppose that Q1 is on and Q2 is off, and therefore VC1 is VC saturation and VC2 is almost equal to VCC. When we want to change the state of the bistable multivibrator, then we need to apply a positive trigger to the base of off transistor, and therefore you will find that now the transistor Q1 will go into the off state and the transistor Q2 will go into the on state. Therefore, the collector potential of Q1 will rises to plus VCC and collector potential of Q2 will fall down to VC saturation. Now, if you want to again change the state of the bistable multivibrator, then again you need to apply a positive trigger pulse to the base of off transistor. And therefore, again, you will find that the state will be changed. The Q1 will be back into the on state and the Q2 will be back into the off state. So thank you, friends, for viewing the session. Hopefully you have understood what is the bistable multivibrator and how bistable multivibrator works. Thank you all for viewing the session.